In this video, we are going to show how to utilize the Desmos Graphing Calculator, which is a resource that we are providing for you guys in helping you determine what the actual shape of the polygon would be given a set of coordinates. And we want to show you the method that is really helpful in visualizing or otherwise showing the visualization of that polygon. So in class for 4.01 exit ticket, at the very end of the slides, you can see posted on your assignment different examples of parallelograms and right triangles. And a set of ordered pairs is provided to you along with some instructions on how to access that. So I want to demonstrate that now. And in order to do that, I want to draw your attention to the upper left portion of the screen where you can see the plus button here. If you click on that, you can click on table, and you can begin by creating a table of values. I've already created the two tables related to the figures for the first two of the three in the notes, and I can leave the third one for you to try out because it is a parallelogram as well as the first one. So this goes with the 4.01 exit ticket, and so that's how you create a table. You just come up to this button right here and click on table, and it's ready to be made. And so with that being said, I'm going to go ahead and start here with this table. Now you will see that this is going to represent, for the purposes of what we're doing, a parallelogram. However, if I go ahead and show you what I have so far, right now the first thing you want to do is make sure that it's visible, which is easy to do. You just click on this button right here and it activates that. So I'm going to turn on the focus for a while because I want to draw your attention to things. So the first thing you do is you type in your points, and there's something that's incomplete about this table right now that you'll notice, and the slides illustrate what that is. I did change this ordered pair here. You'll notice that it's not 5-0, but it's 4-0 because that'll make it a parallelogram. So it's just a little typo, nothing to worry about. So having said that, what you'll do is you'll come up to this symbol right here, the cog symbol, which is our setting symbol, and you'll click that. And the moment you're clicking that, the moment you do click that, you can click on this bubble right here that's now been completely colored in and is solid. And as you can see, there are points on the graph. If you click on this, you'll be able to draw lines. There's going to be a little bit of a problem though. If you recognize that the shape is provided, you'll see that they are not entirely interconnected. This is an indication that we haven't done something right with our table, because if it were right, then every single side of the parallelogram would have a connection or a segment length. And so with that being said, what we want to do is we want to actually complete the table. And to do that, we click on done, and we go back here, and what you need to do every time you type in a set of ordered pairs that represent the vertices of your figure is you need to type in the original point that you started with. And the reason is because you're trying to create what we call a cycle. That means it needs to cycle back to the original point. And this is how the Desmos table reads that completely and totally. Okay? So in some ways, it's really just measuring the segment between the points, right? So if I only had these, 1, 2, 3 was all I got, but now I have 4 segments like I should have. So by going back to the cog symbol, selecting the bubble, selecting lines, you can see that it's already right there and ready to go. I could change the type of lines if I wanted to, but that's just to your discretion how you want to see it visually, and it's not relevant to what you're trying to do now. But now that it's correctly labeled on the table, you can see I have my parallelogram, I should say, ready and available. And in geometry, we want you to try to see the problem beyond your eyes. That means that just because it looks like a rectangle doesn't mean that it is. So successfully what we did was we were able to get the figure graphed onto the plane, the coordinate plane, and the points have now been interpolated, which is just a fancy word for saying we've connected the dots. So you'll also recognize that you can activate each coordinate and you can see the coordinate on the XY plane, which is also a nice little feature as well. If you haven't used Desmos before, it's a very interactive tool. If you drag this around, it will remove those ordered pairs, but you can just re-click on them and you can see them again. Just be careful not to double click on anything. And this is why is this beneficial? Well, the reason it's beneficial is because in your problems that you would have received, you probably were given a list of ordered pairs like the examples on the slide. However, given those ordered pairs, you were not given the actual graph or image of the figure with those points plotted. So sometimes when you have a visualization of the problem, it can assist you in solving. In this particular case, you would probably want to verify that it's a parallelogram. And so an example of how to do that would be right here. So I'm showing you two cases, and the first case is a parallelogram. So what I did was I took the ordered pairs that you see over on the left. You can actually see that I only have the 4 actual vertices, and I used the slope formula up in the far right there to calculate the slope of all of the points. Now, of course, this is a kind of an algebraic approach to finding slope, and what I see here is that the segments that are opposite each other have the same slope. So they are going to be parallel to each other. And that indicates that if you have 2 pairs of opposite sides that are parallel, you have a parallelogram. So seeing that visually as I see it here, that allows me to see what the opposite sides actually are. So for example, I would have needed to pair it up -4, 2, and 3, 4. And I did that. Those are the first 2 points. But I can also verify that I do need to pair those up. I do need to find the slope of that line. And moreover, you can also find the slope by doing rise over run. Right? So for example, I go from 2 to 4 for my y value. So the vertical change is 2. And then I go from -4 to +3. So the horizontal change is 7. Since it goes up and to the right, I have a positive slope of 2 over 7. I can see that from the visualization. So that can help you and assist you when you're trying to, especially if you're a visual learner, okay? So that's an example of how to plot points into your table to verify that it is in fact a parallelogram when you're not given an image originally in the problem. Now I also can activate the triangle here, and I need to go back through the process, but before I do that, I'm going to type in my original point, because in this case I didn't do that yet, so now it's going to be a completed cycle. If I have a triangle, I should have 4 ordered pairs actually in the table. For a quadrilateral, I should have 5, and then so on and so forth. So I'll click on this, click on my bubble, click on lines, and if I wanted to, I could change the color even if I cared about that. Okay, so we'll make it green, I guess. And you can even change the type of points that you want. You can make them stars if you want. All that stuff is kind of just for fun, but it's nice that you have that visualization, and that's a really helpful tool to have. So you see, now I know which points I need to compare, which lines I need to compare. Maybe I'm trying to classify this as a right triangle. How would I do that? Well, remember in class, what we talked about was confirming that the slope of the lines here and here, the segments here and here would be opposite reciprocals of each other. Or that the slopes would have a product of -1. If we confirm that, then there is a right angle here, and that makes it a right triangle. And that's a way that you can verify that as well. And the reason that's important is because I really don't need to do anything with this side length at all. So seeing it visually allows you to see which points are the most important and which ones are kind of superfluous or moot or just not necessary. So showing you that example here, I went ahead and calculated the slope of all 3 lines anyway. However, if I had compared the points to the graph, I would have only found the slope of AB and AC, because those are the 2 lines that appear to be perpendicular, and by finding their slopes I confirmed, of course, algebraically that they're 1 and -1. So I show that their product is -1, and if I do that, then I also realize that the line's segments are perpendicular. Also, 1 and -1 are opposite reciprocals. So because of that, I also know that they're perpendicular, and that means that there's a right angle, which means that it's a right triangle. That's how you can use Desmos to help you create a visualization of the coordinates that are provided to you so that you can better determine what type of polygon it actually is. And that was our main objective for that particular lesson.